Hi and welcome to the next session. And after coupling, we are talking about how to manage that coupling within APIs. I'm Daniel Lübke, very difficult to pronounce last name, so just call me Daniel, or whatever, that's pretty international. So APIs. We are living in a world of many distributed systems where we are offering software services, where we are trying to digitize our companies and organizations. And whenever we do this, we need to probably, in most cases, integrate different software systems. And we do this with different technologies, we do this with different business intents, along business processes, business functions. And we need to build software that exposes this functionality. And if you're thinking about working at a large bank or a large government organization, insurances, or even large tire manufacturers, you have many software systems. And whenever you have a simple thing like placing an order by a customer, there are many systems involved. So like 100 systems in a simple order process. And one thing you need to do as whatever software or API architect designer, you need to make sure that these systems work together so that your order works. And you need to build APIs, you need to build integration, you manage the coupling between those systems. And I have a short and very simple scenario. So let's suppose we are a company who manages or does conferences. And we have some simple use cases there, right? So one use case is we want to have a mobile application where visitors to our conference can browse for sessions, can build their schedule, can look at some further information. So nothing fancy, but we need to fetch data from the backend. We need to make sure that it's the correct data and that the performance is good enough to get this to the mobile device. On the other hand, we have people organizing this conference and they get proposals for talks and need to manage those proposals, accept them or reject them. So we have more business process-like characteristics here. So it's not simple. So the first thing is more simple, quote-unquote simple data management, and the second is more process or function oriented. So it's pretty straightforward, right? And many developers actually think, well, API design thus is very simple. So building these interfaces which expose this data or this functionality to our clients is simple to build. And we all know what happens, so we get some simple things which over time evolve into some not so simple things and not so nice things and not clean things anymore. And the question is, how do we design our APIs better? And this happens every time because our systems are complex. And even if they start simple, they will get complex over time. And it's not that we have any time on the world. We have living in projects, so we have time constraints, we have financial constraints, we have legacy systems in our organization. So it's not a greenfield and happy world scenario. And we have those things, these requirements, which are not functional, but like security, performance. So all these things which are not that easy to handle, and they're very different depending on the organization and where you're in, how many users you have, which data you're taking care of. And so if you start on such a project, you need to be able to say, okay, what are the important decisions I have to make, and thus which are the important questions I have to ask. And it kind of sounds like a checklist. We need a checklist to know, okay, we go there, we ask these things. And the more experienced we are, the better we know this implicitly, right? That's the difference between the senior developers, the senior architects, and junior ones. So they know because they failed quite a lot. They know what they need to do better. They gained this experience. And it would be nice if we could gain this experience without making all these failures. And patterns are a way of structuring experience and making them reusable in a context-specific setting. And patterns in software development have been around for quite a while. And I would say the most important book in software development is the one here in the lower right corner. Design Patterns, Elements of Reusable Object-Oriented Software. And although there are weekly YouTube videos saying that these patterns are not applicable anymore, which I strongly disagree with, I think these are the most successful ones. If we are looking at our programming languages right now, we have these built in. So we are using these patterns day to day. And we are knowing the names. We know what a listener is. We are knowing what a factory is. And it's so common, these names are so successful that we adopted them. And that's why the translated versions of this book are very bad. So I was once in Spain, and well, yeah, I didn't know what they were talking about because observer and listener was something really strange there. So they're building a language where we communicate very efficiently because we have a single word or perhaps two words for describing a very complex solution idea. And these patterns are names, obviously, but they also describe a context and a solution sketch for this context. And most importantly, a pattern tells you what you get and what you lose. So like with all architectural decisions, it's not you get something, but you choose one door. You go to the left door and then you can't go to the right, or vice versa. So you gain something and you lose something. So pattern also doesn't mean, or patterns in general, doesn't mean you need to apply as many patterns to get the best solution. It's about finding the patterns which are best in your context and which strengthen the quality attributes which you want to have, and where you lose in the quality attributes you don't care about so much. And there have been in the last years some community processes around that, some conferences and workshops where we also, on the patterns which I will present, where we also work through these processes to build a good pattern language for API design. Now you may ask, why a new pattern language? Because there are so many pattern books already out there. And the original one was for object-oriented design. We have a quite old one, which is now regaining popularity, enterprise integration patterns, which describes, well, integration, right? So what's the message, what's the correlation key, and things like that. We have service design patterns, we have cloud computing patterns. And from our experience, there was something missing. The question, how exactly should I design this API? How more concrete do I implement this correlation key? Where do I put it in my API? Where is my API, which the cloud computing patterns would say I need to have it? How do I structure this? What information do I put in there? How do I put this information in there? And so we built for 6 years a pattern language which is more concerned with the contents of the messages exchanged between different software components. A message is really meant broadly. It can be a synchronous API, it can be some asynchronous eventing. It doesn't matter. It doesn't matter even from the technology perspective. And we have distilled patterns from existing projects. So it's not we invented patterns, but the process is we are looking at projects which are out there, which nowadays is quite nice to do because you have GitHub and all these things. And we have authors working in industrial settings, so we knew quite a lot of software system which exposes lots of APIs. And then you look at what's reoccurring, what patterns are reoccurring, what ideas are reoccurring. And these are pattern candidates. And from there you work on, and we structured this into 5 categories. And all in all, we have 44 patterns. Now, obviously, in this like 25-minute talk, I can't go through 44 patterns. Would be quite a challenge, but we'll have a look at some of them. You won't see, or if you see some code, let's put it that way, that's just an example. So when I was at university, Corba saved the world, right? So we were eager to learn Corba and were very well surprised that no professor taught us about Corba. And they were telling, yeah, well, it's gone, or it will go eventually. And well, actually, I did then one project with Corba my whole career, although it was supposed to save the world, right? And then we had SOAP, and SOAP saved the world, and XML saved the world, and REST and JSON saved the world, and now we have gRPC and GraphQL and whatever. And I think we all can agree no technology will save the world. And we will have the next integration protocol probably years down the road. But interestingly, many concepts which I have encountered back in this one Corba project, we still have in our APIs today. And so these are things we are building over and over again on top of different integration approaches. And that's what we want to capture, the things which are not dependent on the protocol, but which hopefully are applicable till the end of integration, which will probably never be the case. Let's go back to our conference system, and everyone can probably draft a simple API. We see we have some operations which we need to expose for data and for state, and we just can have a sketch very quickly. And either while doing the sketch or later on in reviews, we come to some questions. One question is, how many endpoints, how many operations should this API have? So if we talk about the state of a submission, for example, a state of a talk, should we have different operations or moving through the lifecycle, or should we have a generic operation which sets the lifecycle state? That's something we need to decide. Do we want to have very coarse-grained operations or smaller-grained ones? Does we put all the data into our messages which we exchange, or do we add links and reference data? So these are all questions which should come up. And this last question, should we put in some data or not? It seems to be very simple, right? So what's the driving force for this decision? And if I talk to developers and API designers, likely 95 or 99% will come up with, okay, it's about the message size and thus performance and network bandwidth, which I require. But there's more to that. And we rarely think about these other quality attributes. And one is consistency. So if we fetch all data at once, we can say it's guaranteed to be consistent. If we put in links and I fetch this data 10 minutes later, might not match the state or is supposedly consistent with the data which I got before. And that's the interesting part about these patterns, because in this list of so-called forces, of influencing factors, of quality attributes, there are many things where we should think about. And if we have a pattern catalog, we can look at these things and say, okay, that's something which is interesting to me, and that's something which I should use in my solution. And obviously the solution sketch here is very simple. I put in the data into my message and have all the data, the whole object graph in my message. On the other hand, I can have the linked information holder, which is my linked data, and this link could be a URL, URI, some ID, some UUID, whatever I can use to resolve this entity via another API call if required. And so we have different alternatives where we can choose from, and we have different quality attributes, and here are only two. So we can make our message larger and thereby decreasing the number of requests of needed calls, or we can make our messages smaller, thus requiring more calls to fetch the data. There are other ways of controlling the size of a message. And another pattern which we identified is the wish list. Probably as a client, I don't need every data which comes there. So for instance, I'm working in a large Swiss project where you can access land register data. And most likely, only a few clients will need 300 years of history data from the land register. Yeah, so 95% of the use cases are the current state. So it doesn't make sense to give me all that data. Instead, you can say, I want to only have the current state. So I wish for some subset of my output. And that's the wish list. I say I'm interested in a certain set of attributes, a certain set of objects. And thereby, I can optimize my return values depending on my use case from the client. And that's obviously what GraphQL does, yeah, in a more sophisticated way. So there I can build my whole object graph, but I could do this with flags and other implementation ways. Yet another way would be to use pagination. So whenever I say I need all this data, but it's too large, I kind of stream it. I say, give me one page, give me another page, give me another page. So I build pages or subsets of this data and request this sequentially. Thereby I minimize resource usage, but again, I have smaller messages, but more calls on my API. And an interesting thing is pagination is already established. Yeah, so usually most developers and most API designers, if you talk about pagination, we have the same effect like talking about listeners. Although this pattern is not as easy to implement because there are very many variants. So two are here is the cursor-based and offset-based variants, where I describe differently which page or which data to fetch next. And depending on your use case, on the data structure, there are certain performance penalties or gains which you can make by choosing either variant. And there are many more in our language. So we could have a request bundle where we put together many requests which are independent of each other and get a set of responses back. We can make a conditional request. So only if this has changed. So all these if modified headers, for example. And we have pagination. And they all play on the spectrum between message size and number of requests. Then we have some patterns which are concerned, should I add something extra to my API or some data? Because all patterns up to now were, how do I transmit the same data just in a different way? And what many organizations have over time is that they have some context propagation. So they're using the context representation pattern where you have some certain metadata which are useful for monitoring, for logging, for authentication, and all these things. So here's some examples. So user tokens, message IDs, business process IDs, time to live, when was this message sent, is it, in which environment does it belong to, is it a productive message, is it a test message? So all these things can be bundled in a common context representation which can be used and which can be inserted in the message itself. So in contrast to using HTTP headers, by putting it into the message, you're getting protocol agnostic. So you could just put your HTTP request into message queue and you don't lose anything. You don't need to map these things. And then we have patterns which are concerned with how you evolve your API. So there are people who are saying, well, there's no breaking change never, and I've never seen that. At some point you will have breaking changes. We now have the euro, and before we have all these national currencies, there was a breaking change, and no software could just say, oh no, I'm keeping German marks because I'm supposed to stay backwards compatible. No way. So we have breaking changes. either by our external environment or because we are trying to refactor things. Want to make things simpler. And then you need to have some kind of strategy, and there are different ones. A very common one is two in production, where you separate different versions and offer two, hence the name in parallel, so people can migrate to the newest one before you phase out the old one. You can use deprecation, so there are alternatives and alternative patterns which we describe. And so that was just a short introduction, a short overview. And Cesare will dive deeper into some of these in the next talk, but there are some pointers. So we've done lots of podcasts, and we have a pattern homepage where you find all these patterns, and obviously we have the book and the signature series. And if you want to get all these links, just go to my Twitter account, and there's a pinned tweet where you find the links to all these interviews and materials and things, so you don't need to copy the slide, photograph it, or whatever. Yeah, with that, I'm in time, hopefully. At least the moderator hasn't complained. And I hope that you got something, you find these patterns useful in your future API design work. And if you have any questions, just contact us or go to Twitter and get to the additional resources. Thank you very much.
Okay, we thank you. Thank you, Daniel. And actually, I don't have a complaint. I have quite the opposite. So amazing time management, amazing talk. And there's an interesting question by Mirko, not your co-author. He connects your talk with the previous one by Vladik, because he asked about balancing. So in Mirko's words, in my experience, patterns can be useful in some situations, but sometimes they make the code less readable and not so intuitive for another developer who doesn't know that pattern, especially for the more complex ones. So his question is, how do you usually find a balance between using and not using patterns in your systems?
Well, I think it's not a question of balance. It's a question of whether the pattern is applicable in that context. And that's what many people do wrong, I think. So especially if you're in a university and teaching patterns, and then students go out and, yeah, we've used all 20 of those. And you say, oh, well, but I did something wrong in teaching then. So really look at the context and of the forces and whether this helps you and your case and your requirements or it doesn't. And if you go out with 0 patterns, then it's fine. If you go out with 10, it's fine, as long as you solved your problem and these patterns help your problem or help you solve your problem. So it's not about balancing, it's about finding appropriate patterns.
Okay, thank you very much.